Welcome back. Problem 11-15. So statement is two acetyl plastic member are to be glued together and are used to support the loading shown. If allowable bending stress for plastic is 13 ksi and allowable shearing stress is 4 ksi, determine the greatest load P that can be supported and specify the required shear capacity of the glue. So you can see the cross section. This is plastic 1 and this is plastic 2. They are glued together and the load P at two different points is applied. Clear? The allowable stress and allowable shearing stress is given, so you have to find this P that can be applied on this beam, and you have to find the shear capacity of this glue. So let's start with the solution. So first we know that maximum bending stress is equal to maximum bending moment into C divided by I. So we do not have maximum bending moment. So what we will do is that we will find the shear force and bending moment diagram. From there we will get this maximum bending moment. So for that, if you remove this support, so you will have to represent a reaction force. Let this is R1, and if you remove this reaction, so there support, so there will be a reaction force which is R2. So we'll first find R1 and R2 by using equilibrium condition, that sum of all moments about point 2 is equal to 0. This is point 2, this is your point 1, and taking the counterclockwise movement as positive. So about point 2, one moment is due to this P and perpendicular distance is 5, that is producing counterclockwise, so it will be plus. The second moment is due to this load and perpendicular distance is 10 feet, and that will produce counterclockwise, so it will be also positive. Third moment is R1 into perpendicular distance is 15 feet, and this will produce clockwise, so it will be negative. So their sum must be equal to 0. So I will write P into 5 plus P into 10 minus R1 into 15 is equal to 0. So from here we have 5p, 10p is 15p. So 15p minus 15r1 is equal to 0. It means that r1 is equal to p. Now we can find R2 by using this equilibrium condition, that sum of all forces along y direction must be equal to 0. So R1 plus R1 minus P plus R2 is equal to 0. So R1 minus P plus R1, which is P, is equal to 0. So from here you will get R2. Sorry, this is this R1 is P, so we will make it R2. So R2 is equal to P. Now you have R1 and R2. You can draw the shear force and bending moment diagram. So I will draw vertical lines from the end of this beam and will show you. Let each division is equal to P. So here we will take shear force that will be equal to kip, because the stress is in KSI and this X is in feet. So now you can see that at this point we have R1 which is equal to P, and so we will plot it. This will be your first point, P plus P. Now moving from this till this point, there is no other force, so this P will remain constant. So this will remain same till this point. This is P. Now you can see at this point we have minus P, so P minus P is equal to 0. So shear force will move from P to 0. Again, moving from this point till this, there is no other shear force, so it will remain 0 till this point. And you can see now here that you have a load of minus P, that this will go toward minus P. So I will draw it. This is your minus P, and then it will remain same till last point, and at end you can see R is equal to plus P. So minus P plus P will bring it to 0. So this is your shear force diagram. Now we'll draw bending moment diagram. So again X will be in feet. You have moment, clear, that will be equal, the unit will be kips into feet. Okay, so let one division is equal to 2.5 kips into feet, so 2 will be 5. Similarly, this will be minus 2 this is minus 5 kips into feet. Now first area under the shear force diagram, this area is equal to P into 5, which is equal to 5P. Clear? So we will plot that this is your 5P, and it will be a straight line because you can see that shear force is a horizontal line with 0 degree. So bending moment will be 1 degree higher. Now this is 0 area, so it will remain same till this point. So bending moment will remain same, that is 5P. This is 5P plus 2.5. Now the second area is this area, and this is again minus 5P. So plus P minus 5P will bring to 0. So your bending moment will be this. Now from bending moment diagram, you have maximum bending moment is equal to 5P, and the unit will be kips into feet. So if you convert it into inch, so you will multiply 5 with 12 into P, and the unit will be now kips into inch. So it will be equal to 60P. So this maximum moment 60P is in, the unit will be kip into inch. If you are using feet, then you will use this 5P. Now what we will do is that we have find out this maximum moment. So again you will find C and I for this. So for that I will draw it over here. So let me draw it first. This is the first one, and this one is the smallest one. Okay, so what was the dimension if I draw it? So this is 8 inch. This is 8 inch. This height is 6 inch. This height is again 3 inch. And this width is 3 inch. Now you can see that this is not a regular shape, clear? So we'll first find its neutral axis. Find neutral axis. Where will be the neutral axis from this base? If you select this as a base and you want to locate the neutral axis from this base, so you will find that y dash or y bar, and this y bar can be find out by using formula that sum of y dash into a divided by sum of area. So you can see we have two. One is this one, second one is this one. So the first area is 8 into 6, clear, and its centroid from this base is 6 divided by 2, which is 3. So I will write it 6 into 8 into y dash, which is the distance from base till the mid of this, plus Now we will have this section. So the area is 3 by 3 and its centroid is 1.5 and this is also 1.5. So from base till this center, this is equal to 6 plus 1.5, which is equal to 7.5. So I will write 7.5 multiplied by 3 multiplied by 3 divided by sum of area. So first area was 8 multiplied by 6 plus second area is 3 multiplied by 3. So when you solve this, you will get y bar is equal to 3.7105 inch. So it means that its neutral axis lies at a distance of 3 point, this is y bar, and that is 3.7105 inch. Now what is this is the neutral axis. Now we'll find the moment of inertia I, and that is for rectangular bar is 1/12 bh cube. So we have now two. One is this one, so its breadth is 8 and height is 6, and its centroid is at a distance of 3 from this. So we will use parallel axis theorem because the neutral axis is away from its centroid. So this will be your D. So by using parallel axis theorem, 1/12 breadth is 8, height is 6 cube plus this area which is 8 multiplied by 6, and what its centroid of the first is at a distance of 3 from this base. This is 3. So we will left with this distance, and this distance is D, and this distance is equal to y dash minus this 3. So y dash is 3.7105 minus 3 square because AD square. Okay, plus now we will talking about the second portion. So 1/12 base is 3 and height is 3 cube plus area 3 multiplied by 3 into D square. Now you can see this D is the distance from this centroid till this. So if you look that this distance was 7.5 inch. So if you subtract y dash from 7.5, so you will be left with this distance, and this is your D. So I will write D is 7.5 minus 3.7105 whole square. So again, when you solve it, you will get the moment of inertia of this whole cross section, that will be 304.22 inch power 4. Okay, now we will talking about C. So C is distance from neutral axis till topmost. So you can see total height is 9 inch. So 9 minus this y dash, which is 3.7013, will give you this distance C. So I will write it C is equal to 9 minus 3.7105, and the unit will be inch. So you have maximum bending moment, you have I, you have C. You can put it in formula. Maximum bending stress is equal to M into C divided by I. So moment was in kips into inch is 60p. C is 9 minus 3.7105 divided by I. What about I? I is 304.22. So when you solve this, again you have been given sigma max is 13 ksi. You can check it. This is 13 ksi. So you can put 13 is equal to 60p into 9 minus 3.7105 divided by 304.22 and when you solve this you will get P for this bending stress comes out to be 12.462 kips, or you can say P is equal to 12.5 kips, and this P is calculated based on bending. Now we will check it for shear as well. So shear force for shear stress as well, because we know that maximum shearing stress is equal to V max into Q divided by I. So V max from shear force diagram is equal to P. I will check you can see this is P, clear. And Q is, what about Q? So we will find Q. We know that at neutral axis we have a maximum shear stress. Neutral axis we know. So at neutral axis we have maximum, and maximum shearing stress is given as 4 KSI. So we will put it 4 is equal to P. Q is equal to, we know that Q is equal to A into Y dash. Clear? So area about the neutral axis. So this is your neutral axis. This is your neutral axis. So area above or below the maximum area. So this is the area, and this area is equal to 8 multiplied by 3.7105. Clear? And its distance from Y dash will be the half of this. There, so I will write it. P into Y dash is 3.7105 divided by 2, and area is 8 multiplied by 3.7105 divided by I. I is equal to 304.22. So when you solve this you will get P is equal to 177 kips. That is for shearing stress. Now we will also check above blue seam for this shearing stress. So again, this shearing stress is 4 is equal to P divided by I, which is 304.22 into T. I forgot about T, which is here it is 8. I will show you. I just forget it. You can see this thickness is 8 inch. Now we are talking about the area above the blue seam. So this is the area which is 3 multiplied by 3, and its centroidal distance from neutral axis is this one, which is, again you can see this total distance is 7.5. So 7.5 minus this Y 3.7 something will give you this this distance, this one, which is Y dash. So we will put area is 3 by 3, and distance of centroid from the neutral axis of this seam, blue seam, is 3.7105. So and thickness is 3. You can check it. This thickness is 3 of this seam. So when you solve this, you will get P is equal to 107 kips. Now we have 3 type of loads. These 2 are due to shear and 1 is due to bending. So we will choose P is equal to 12.5 kips, which is the smallest one, because this can, if this P is used in this and this will be less than the allowable shear. But we cannot use this value or this value in this formula and it will exceed the maximum bending stress. So we will choose this 12.5. Now we will talk, this is the answer of our first part. Now we will talk about glue strength. So for glue strength, shear strength, which is the required, is equal to V into Q divided by I into T. So V, which is equal to P, and P is calculated as 12.5 kips. Okay, so 12.5 divided by I is 304.22, and the glue area where thickness is 3. And what about Q? So Q is this is the same, just like this one, this portion. So this area is 3 by 3, and its neutral, its distance from neutral till centroidal is 7.5 minus 3.7105, and this thickness is 3. So you'll just put the value 3 multiply by 3 multiply by 7.5 minus 3.7105. So when you solve it, you will get required strength of glue comes out to be 466 psi. And this is the answer of our second part. I hope you have enjoyed this video and you have learned from it. Although these are very lengthy problem, but if you learn them, you will be definitely, it will help you in solving other problems. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.